In this video, I wanted to go over how we can use technology to calculate some measures of center. Before getting into the technology part of this, I just wanted to kind of rehash and remind ourselves about some definitions that we'll be using throughout this video. So if you recall, Q1 is a symbol we use for the first quartile. What does it mean to be the first quartile? The first quartile is the data value in which 25% of the rest of the data is less than or equal to that value. The median, also sometimes referred to as the second quartile, is the data value such that 50% of the data is less than or equal to that value. And then third quartile is means it's the data value where 75% of the data is less than or equal to it. Also, we'll be talking about the interquartile range. The interquartile range gives us the range or the spread of the middle 50% of our data. And how does it do that? It takes, and there's a little bit of a typo here, it takes our third quartile and it subtracts away the first quartile. Well, how does that give us 50%? Well, remember the third quartile is the 75% or less than or equal to that. The first quartile is 25%, so 75% minus 25% gives you the middle 50%. So the IQR, the formula for that will always be the third quartile, Q3 minus Q1. A few other little bit of tidbits here is that if our data is skewed, we should report the median and the IQR. Because of that skewness, the mean will be affected by outliers. So therefore, if the data is skewed, you're best off using the median and the IQR to represent the data set. If the data is symmetric, on the other hand, then we can use pretty much anything. We can use the mean, the median, or the IQR because the data is symmetric. Also, if the data is symmetric, then we say that the mean should be approximately the same as the median. Will it be exactly the same? No. But we're saying that the mean should be pretty close to the median. However, if the data is skewed left, right, and we have some examples of histograms below here, but if the data is skewed left, the mean will be pretty significantly less than the median. And that's because the smaller data values in that left skewed distribution is pulling the mean to the left. And on the other hand, if we have a skewed right data set, the mean should be pretty significantly more than the median. You see this a lot when it comes to reporting salaries of different careers, right? Obviously, the longer you've been in your career, we hope that you have a higher salary. That's a right skewed distribution, salaries. But that's not indicative of a person that's just getting started in that field, right? So that's why when it comes to salaries, we typically like to represent the median value because of the right skewed distribution. And really quickly, just a quick little refresher on what we mean by skewed and symmetric. Here's a picture of a few histograms here. And so we can see in the histograms here, these are the representative of the different types of distributions that we may come across, right? So the top left distribution here is symmetric, right? If we were to draw, I don't know if you guys can, hopefully you can see my mouse here, but as we kind of follow along the heights of those distributions, we can remember the tipping point is the median pretty much. And so we see that it's pretty much the same both on the left and right of that tipping point, therefore it's a symmetric distribution. Skewed right, if we do that same thing, if we go to that tipping point, we notice that we have a long right tail. And that's why we say that's a right skewed distribution. That's indicative of we have a lot of data values that are kind of towards the lower end of the spectrum, but we have a few larger data values. Then the opposite is true for skewed left. Skewed left, we have a lot of the data values are kind of bunched up to the right, and then we have a few smaller data values. And then here's some other examples. We have bimodal, right? So bimodal means there's like kind of like two modes. That's what bimodal means literally, but there's like two kind of peaks. So we have a peak here, and then we also have a peak towards the right. And then the multimodal, you have more than two modes, right? We have a mode here, we'll have a mode here, we'll have a mode here. So this looks like a trimodal distribution. Anyways, I just wanted to show you guys, remind you guys about the different distributions. Now let's get into an actual example of how we can use technology to calculate the various measures of center. All right, let's consider this question here. The National Center for Education Statistics reports average mathematics achievement scores for 8th graders in all 50 states, the District of Columbia and Puerto Rico. The scores for 49 of these locations are in the accompanying table. They want us to complete parts A through C. So first of all, let's take a look at the data set. So you click on the icon, and here's our data set. We have the states, and then we have the score, the mathematical scores of 8th graders in those respective states. Okay, so the question wants us to calculate the mean, or excuse me, the median, the IQR, the sample mean, all of those good things, right? So in order to find that, we're going to use some technology. I am going to show you how to use the program that's baked into our homework platform. It's called Statcrunch. I'm going to calculate the statistics using that. But if you have any questions about how to do this in Excel spreadsheet or how to do this in your TI 8384 calculator, by all means, send me a message and I can help you out if you prefer to do it that way. But to get this into Statcrunch, what you do is you click this icon. It looks like 2 windows. Open in Statcrunch. All right, make sure you allow your pop-ups. And boom, it automatically copies our data set over into Statcrunch, which looks like an Excel spreadsheet, kind of, sort of. Notice our first column is the states, and then our second column are the mathematical scores. Okay, so now how do we get those summary statistics? How do we get like the mean and the standard deviation and all that stuff? Well, it's pretty straightforward. What we're going to do is we're going to go to our stat option. So Statcrunch applets edit data, go to stat, and we want to calculate the summary statistics. And so it wants to know what type of summary statistics are you calculating. We're going to do it for the column of score, right? Because the column of score has all of our data values. So when we go to summary statistics, we're going to select columns. Okay, so the first thing we should do is it needs to know for which column or columns does it need to calculate the statistics for. And so we want to do it for the score column. So you click on score and it'll populate over here on this right column, okay? Next, it wants to know where do you want the output. I like to just keep it as optional. Group by, don't worry about group by. And then statistics, it wants to know, okay, so what statistics do you want us to calculate? Well, I want N, which is the sample size, how many data values we have. I want the mean. Okay, so if you need to select more than one option, what you do is if you're on Windows, you hit Shift and then you click it. Or if you're on Mac, like I am, you hit the Command button and click. So I'm going to select N. I want to know the sample size. I want to know the mean. I want to know the variance. I want to know the standard deviation. I certainly want the median. I want the minimum data value, the maximum data value, and I want my first and third quartiles. And while I'm at it, let's go ahead and get the IQR. Okay, everything else we don't really need to worry about. We're not worried about percentiles, and we're not worried about the other statistics. It has everything that we need. The output, I tell you what, let's go ahead and store that in the data table. That'll be a little helpful for us. And then let's compute. And okay, so they're just telling us we've added stuff to the table, but here, let's close this out. And if you notice in our table, it calculated all of the data values for us, right? So for score, they tell us the number of data values, the mean, the variance, the standard deviation, the median, the minimum, the max, the first quartile, the third quartile, and the IQR. So that is fantastic. So let's keep this open, but let's make it a little smaller. And let's go back to our question at hand. Okay, I'm going to clear out this table. And let's do it like this. Okay, so first question is, what is the median? That's very straightforward. In our data set, in our output, we see the median is 280. So I'm going to type 280. Okay. And you don't have this option, but check my answer. Yeah, that is correct. Good job. All right, what's the IQR? So remember, as we said earlier, the IQR is Q3 minus Q1. Well, if we go back to our table, Q3 is 286, Q1 is 276, 286 minus 276 is 10, and we see that in the IQR column. So our IQR is 10. Absolutely, this is great. Okay, the sample mean, they want to know what's the sample mean. Well, the mean is 279 and some change. So they want us to round this to 1 decimal place. So it'll be 279.8 because it's 279.77. So to 1 decimal place, 279.8. All right, what's the sample standard deviation? That is the standard deviation that is reported to 2 decimal places. It's going to be a 10.41. 10.41. Let's check that answer. It's looking good. All right, which summary statistics should be reported for these data and why? So remember in the first part of this video, we talked about, the data is skewed, we should report certain things. If data is symmetric, we should report certain things. Well, how do we know if the data is skewed or symmetric? What we could do is let's look at the box plot. Okay, so let's do that. So in order to calculate a box plot, we can actually do that in Statcrunch. Okay, so what we're going to do is it's under the graphing option. So we're going to go to graph and we're going to go to the box plot option. Okay, and so it wants to know, once again, what column for which are you calculating these things for? So we're going to do it for, once again, the score column. All right. Optional where we could place this. Don't worry about that. Group by, don't worry about. And then plot groups for each column. Don't worry about the grouping options. However, I do want us to, I like to draw my box plots horizontally. It just makes it a little easier for me to visualize the skewness of the distribution. So check that horizontal, draw boxes horizontal box, okay? Everything else you can leave alone. Let's go ahead and compute. And here we go. We have our box plot. And apparently we have an outlier. If you remember the slides on outliers, that dot indicates an outlier. So if you could imagine kind of drawing a curve that mimics this box plot, we're going to see that our median, remember the middle line here in the box itself is the median. The median is at 280. So that's where the tipping point kind of the distribution would be, right? So if we look at that, it's going to go something like this. Is going to peak around that 280 and then come down here. We'll notice that we'll have a long left tail. So this is certainly a skewed left distribution. So because of that, when we come over here to our question here, since the distribution is, well, this is pretty skewed to the left, we should report, since it's skewed, we should report the median, right? And then we should also report the IQR if we're worried about the spread, right? So the median is used for the center. The IQR would be used for the spread of the data set when it's skewed. Let's check that answer. Good stuff. Write a brief summary of the performance of 8th graders nationwide. The distribution of scores is, well, we said earlier, it's skewed to the left. Okay. The center, okay, so because it's skewed, the center we should use is the median. So the median we said in the earlier part is 280. Okay, once again, use the median when it's skewed. You use the mean when it's symmetric. The middle 50% of the states scored between 2 values. Well, that's the IQR, right? The IQR is between Q1 and Q3, the difference between those, right? So what was Q1? Q1, if you go back to our data set, Q1 was 276. And Q3 was 286. All right, let's check that answer. Fantastic. All right, so that was just a quick little video, folks, on how to use Statcrunch to calculate various things such as box plots and our summary statistics like our mean, our IQR, our median, and our standard deviation. All right, hope this helps. I'll see you guys in the next video.